and welcome to my presentation of WeakAL combining active learning and weak supervision. My name is Julius Gonsior and I'm from the Technical University of Dresden. Supervised learning requires a huge amount of labeled data. To make labeling more efficient is one of the most critical components of the success of machine learning. Big companies like Google trick their users to label the data for free using their CAPTCHAs. Other companies use, for example, Amazon Mechanical Turk for that one. The traditional approach is random labeling, where you just let users randomly label one sample after another one. So you first label, for example, the first row and then just the second row, and you label all the samples. That example, 14 labels were needed. And let's just assume that these three and these three and these three, that they are all quite similar, these samples. So a lot of redundant labels samples were being labeled. A more sophisticated approach is active learning, where one tries to actively decide which sample to label next based on the informativeness of this sample to the overall classification problem. So in the first iteration, one only samples, for example, these three samples, after that only these three. So in total, one has now only labeled 6 labels instead of 14 before, because we didn't label all these redundant labels, but only one out of these groups. And by doing that, we could still have a similar high accuracy. Another approach is weak supervision, where we start with a set of labeled samples, and then we would automatically compute some labels for these samples. But it is called weak supervision because they were being computed automatically, they could be wrong. And we do this until all samples have been assigned an automatic label. The big drawback is there's no human supervision included, and therefore this approach is prone to overfitting. We propose therefore to combine active learning and weak supervision into WeakAL, where we start with a set of labeled samples being generated by active learning. Then when we are sure that we know a little bit about this problem, then we can apply weak supervision to generate some samples automatically. But then we do again active learning, and only after that we do weak supervision again. And so now we have kind of in human supervision of the weak supervision. So it is now an iterative process where we include the human experts, and we get now the benefits from both worlds, from active learning and from weak supervision. So how does a standard active learning cycle look like? We start with a set of labeled data and a set of unlabeled data. Then we train our model on the labeled data set. Then we select from the unlabeled data a small batch, and then we let a human expert, or we use the gold standard, to increase the set of labeled data, and then we continue this whole cycle. And we do that until the stopping criteria are met, and then we just end this whole cycle. And these stopping criteria are a big weak point of active learning, because it is hard to determine an ideal stopping point. If you don't determine a stopping point early, then in the end you label all samples, and then you could have just done a random labeling from the beginning. So we propose to combine weak supervision into that. So the first change is that we have here some weak supervision thresholds, and only if those thresholds are met, then we apply weak supervision, which means we automatically generate some more labels. Otherwise, if we aren't sure enough to do weak supervision, then we do this whole active learning route, where we let the human experts do the labeling for us. And another change is that now we have a pre-clustering, and in this active learning part we only select queries, a batch of queries from one single cluster, which has benefits for one of the weak supervision strategies, which I'm gonna explain now. So we've included 2 weak supervision strategies. One is weak cluster, the other one is weak search. For the first one, For a cluster, we use the most prominent label and then we just propagate it to the whole cluster of samples. And for weak cert, we use the prediction of the classification model. And when the confidence for this prediction is high enough, then we just assume that this is the real label for these samples. The WeakAL has several challenges. First, we have now a lot of parameters. First, we have all these active learning parameters like the query strategy, the batch size, etc. And then we have all the parameters for the weak supervision in addition to that, like the threshold before we apply weak supervision, etc. And then we have the, as we call it, the accuracy saved human effort dilemma. Where on the one hand, we want high accuracy that equals high safety thresholds before applying weak supervision. On the other hand, we want to save as much human effort as possible, which equals low safety thresholds, which would be a lot of weak supervision. And both goals can't be brought together, so one need to find somehow a golden middle. We did an extensive feasibility study on real-world datasets. We've selected 6 datasets. 5 of them are from the Active Learning Challenge, which was being held in 2011. We have a lot of datasets from a variety of domains. We have binary classification tasks and multi-class. We have not so many features, datasets with a lot of features, datasets with medium size of samples, and really large datasets. As mentioned before, there are a lot of parameters in WeakAL, and we did therefore a large hyperparameter search, where we try to find out a subset of parameters which consistently perform better with WeakAL. And we've actually did found such a subset. So this is the distribution of the final accuracy per hyperparameter combination. And one can see there is a subset of hyperparameters which are around 3% better than doing standard active learning. But if you choose wrong labels, wrong parameters, then you're actually worse. The results for one dataset in detail. Blue means that the labels were generated by the human expert. Orange and green means that the labels are coming from weak supervision. And you can see, so after around 1,000 labels, almost all labels can be generated automatically by the weak supervision, but sometimes still some samples need to be labeled from the users, because otherwise the accuracy would probably could drop too far because of the problem of overfitting. And so you can see that almost all samples can be generated automatically. For a smaller budget means the amount of labels from the human expert. Of course, more labels are being generated by the weak supervision, but the end accuracy is of course lower. That means now we have a less high accuracy, but we could save more human effort. So the safety thresholds were lowered. Here are the results for the rest of the datasets. To the left, the saved human effort. That means the percentage of the samples which are being generated automatically by weak supervision. So for most of the datasets, almost all samples could be generated automatically. The final test accuracy is still pretty high, and combined score is just the harmonic mean of the first 2 columns. And then the global score. This is the final metric from this Active Learning Challenge, and with our results, we are in the top 5% of the competitors. To conclude, in a standard supervised learning settings, you need experts, time and money to generate all the labels, which is a cumbersome task. Therefore, active learning is a smart way to actively check which samples are the best to label next. Weak supervision is also a nice approach to automatically compute the labels, but both techniques have some drawbacks. And if you combine them in an iterative manner, like in WeakAL, which we propose, then you get the benefits from both worlds. So you don't need to label all samples, but you still have a high accuracy. Thanks for your attention, and if you have any question, feel free to ask.